Okay. Okay. First of all, today, I really want to thank the oceanographers at the University of Puerto Rico for giving me this really nice tour of the weather balloon at La Paguera. It's really cool up here. Jim Joyce was right. But anyway, what I wanted to talk about today, this is going to be our last weekly video for the epistemology seminar. And what I wanted to do today was really take some of the ideas that we've been thinking about, that we've been going over in this class, and see how they apply to a sort of real world issue, an issue that gets us involved in some scientific matters. And we can look at what we've learned today. And so I want to take a debating stance. I'm going to take this stance. Let me get to that if I can see what I'm doing here. Yes, I can. That is today what our last topic will be. It's, again, a real topic. Jeez Louise. There you go. Do we know that there's intelligent life in the universe? Now, I'm going to say intelligent life in the universe. I'm going to mean intelligent life other than intelligent life here on Earth. If there is any intelligent life here on Earth, yes, I do spot that joke as well. Thank you. And I'm going to argue this. And again, this is kind of summing up some of the things that I've said in class today. This whole project wasn't in order to make this argument, but I think it's an argument that we can make. And that is this. I will argue that we know that it's a legitimate, coherent and meaningful, but also correct use of the verb to know, to say that we know that there's intelligent life in the universe. Again, a life other than ours. And I'm going to give you epistemological arguments for that. I'm going to say that based not only on the kind of evidence that we have, but also on some of our standards of knowledge, we do know that there's intelligent life in the universe on other planets. We know this with certainty. That is my claim. And I think we have known that for a long time. The philosopher Kant was, felt that he knew that, whether he was wrong or not. I think he might not have been wrong in the late 1700s. Really, for our money, it all started with Galileo. I would mention that the pre-Socratic philosophers, and no doubt many other people throughout times and places, Thales heard that a large meteorite had come down in Ionia sometime in the 5th century BCE. And he went out and examined the rock, and he concluded from looking at it that the rocks up in the superlunary realms, the celestial realms, the heavenly realms, were the same as the rocks down on Earth. So Thales said that a very, very long time ago. But the modern confrontation with the universe, in a sense, really starts to happen in the 17th century with the rationalists of the 1600s, and particularly the astronomers of that time. Notably the big superstar Galileo, who built his own telescope in 1609. The refractive lenses coming in, and you also had microscopes, notice, so they didn't know that there were microorganisms and plant life and things like that in water until right around that time. Was the late 1500s that you first started to get the Dutch lens grinders making microscopes and then telescopes, and Galileo built his own telescope. So I'm going to talk about a couple of the preliminary observations that Galileo made, but the reason I'm going over them is pointing out that they give us reasons for thinking that there's intelligent life in the universe. He saw the mountains and the craters on the moon. You can do this with there's binoculars. He even worked on sort of calculating some of the altitudes of some of the mountains on the moon and that sort of stuff. But in any event, what he took, the rugged terrain that was evidence on the moon, you can see it very easily if you look at the edge of the moon, the horizon of the moon, you can see the mountains. It's quite something. It looked to him like very strong evidence that the celestial realm was the same as the sublunary, that is under the moon realm. People like Aristotle thought that maybe they had sort of idealistic or Platonic ideas that perhaps the moon was a perfect sphere and these celestial objects were perfect spheres moving in perfect circles and so on. And the whole story of astronomy in the 1600s is showing that the objects in the nighttime sky weren't anything like that and were all very messy and very natural looking indeed. And this is what Galileo shows. He also showed that there were multiple moons orbiting Jupiter. It looked to him like a little mini solar system. You got to think of looking through the microscopes and seeing things that look like little mini solar systems. But for our purposes here, another thing about seeing all of the moons orbiting Jupiter is that Galileo saw that that meant that everything was not in orbit around the Earth. There were things orbiting around Jupiter after all. And this notion that Earth is in the center, and I would suggest, I'm going to get back to this at the end of the presentation today, I think it's that old mind-body dualistic theocratic worldview still kind of baked in there, is why we really have what looks to me like a knee-jerk and not very rational response to the issue of intelligent life in the universe. Galileo made the first step in decentering. He proposed a heliocentric model, that the sun was in the center of the universe and not the Earth. And then, of course, gradually everything became decentered. Even the galaxy became decentered among other galaxies. So what's, again, for our purposes, thinking about the proposition that there is intelligent life in the universe, well, so you've got the humans were supposed to be miracles, right? The humans were supposed to have immortal souls and not be like the rest of the animals. And the celestial spheres were supposed to be perfect and describing perfect circles and without any imperfections. If we decide that's not the case, and we look around at nature, we go outside in the yard and look around at the natural world that we live in, and we decide that both the celestial realms, the superlunary realms, and human beings in their nature and their essence are not any different from the rest of nature, then there isn't any, I use that phrase a priori, there isn't any before the fact, before investigation reason for thinking that there isn't life throughout the cosmos. There's reason for thinking that there is life throughout the cosmos because there's life in our local area. And I'm going to, just to really make another point of that, because this is, as I say, it starts with Galileo, but this evidence goes on and on. Spectroscopy is a really important part of modern astronomy because different elements have different radiation signatures. So you can actually tell what element what are the elements that compose a celestial object that's giving off radiation by running the light that it emits through a prism, through a spectrograph, and then you can find these fingerprints of different elements as well as different molecules. You can see the molecules that things are made out of. So this kind of spectroscopy is a really important part of modern astronomy. What we find is that the mix of elements that we see in our local area is roughly the same, practically the same mix of elements that we see out to the event horizon as far as we can see. Notably, hydrogen being the most common element in the universe. Hydrogen the most common element here, but when we look through our spectroscopes at the rest of the galaxies, we see hydrogen as the most common element out there as well. And hydrogen, of course, the key element, so far as we know, in the emergence of organic molecules from inorganic ones, in the emergence of life. So yes, Galileo starts it. Galileo looks at the moon and sees the mountains there and says, it's rough up on the moon just like it is down here. They have mountains like we do down here. We look through the spectroscope and we see hydrogen is the most common element in the universe. And we think, gosh, then the same kinds of chemical events that are happening here in our local area are happening all through the universe. You know, we have more than enough reason to think that. I mean, you think you know how hydrogen interacts with other things and you see that there's hydrogen all over the place. You would have to think that, well, maybe there was, you would have to doubt it, that these organic processes are happening all through the universe. You would have to believe in some kind of miracle, that somehow the things that you took for granted as lawful around here weren't lawful other places. But there's more. There's lots more. It's been a long time now since the 1950s. We get the Miller-Uray experiment. Basically, the deal is, I mean, think of like a terrarium, right? Like a big glass box, and you put a light bulb on one end of it and just have darkness on the other. So you have a heat source and a heat sink. So you have energy moving through it, and you put a couple of really basic elements into water, and they start forming into chains of amino acids. It's not hard to get them to start forming into chains of amino acids. There are various kinds of amino acids, and actually, the Miller and Uray identified a number of different kinds of amino acids that they detected in their apparatus. Years later, though, people with better technology actually went over their samples and found that they had actually produced a lot more kinds of amino acids than they thought. They had actually proved more than they thought. And so think of a star, it's putting out this energy, and then the surrounding space is the heat sink. And you have these planets with atmospheres orbiting around that, and that's like your terrarium. It's got a flow through of energy, so it's got that dynamism. And, you know, so this is what is observed. Look at Earth. In Earth and Antarctica, there are microorganisms that live inches below the ice. Even more amazing, down at the sea vents at the bottom of the ocean floor, there's life, because there's heat there, but that is under unbelievable pressure because they're so deep in the ocean. So, but just think about walking down the street and notice the plants growing up through the cracks. You know, here in Puerto Rico, I mean, if you leave something, you don't tend it, the jungle's going to come back and grow back over it again. Life is everywhere. We see on our planet, life pushes itself through the little cracks. It gets in everywhere that it can. That's what we see, and we see it very consistently. You know, human life, well, think about life in general. And again, if you think humans are somehow miracles, then I guess, you know, I don't know what to think of you. Oftentimes people will mention something called the Drake equation. Now, probably the Drake equation is a quite reasonable thought experiment. That's what it was when Frank Drake did it in 1961. There was a meeting of people thinking about looking for extraterrestrial intelligence, and he wanted to get the discussion going. Of course, they had absolutely no data at that point. And so he just tried to figure out what an equation would look like. You'll hear people talk about the Drake equation as if it came up with some sort of hard estimate. And you'll also hear people invoke the Drake equation as somehow an argument against abundant intelligent life in the universe, which is not. But basically, you're looking at fraction. You've got the fraction of the number of stars that gets formed that are ones that will have planets, the fraction of those that have planets that can support life, the fraction of those that actually do have life, and so on, down to the fraction of the ones that are sending signals into space. And then Frank Drake actually realized when he was putting that together that, oh, this would be actually an estimate of the amount of intelligent life in the universe. That wasn't really what he set out to do. But the thing about the Drake equation is that the variables are so big, and I'm going to talk about really big numbers in the next slide, I believe, that it doesn't prove anything. Drake ended up thinking, he said, well, maybe there's between 1,000 and 100 million intelligent civilizations in the Milky Way galaxy, right? One of millions of galaxies. The Great Wall has billions of galaxies in it. It's the largest known structure in the universe. But, you know, the variables can change by, you know, factors of 100 all over the place. So I mean, since we don't know the variables, and by the way, notice at the last one, in any event, now we have just simply better observational technology. And now it turns out that there are a whole lot more exoplanets, planets around other stars than ours, than was previously thought. Whatever the estimates were and whoever was making them, and for whatever reasons. The fact of the matter is, over the last 20 years, we've been going through a revolution. In fact, we are living through one of the greatest periods of discovery in all of human history. We're living through the period of the discovery of the exoplanets. And that's one of the things that's going to pick out this period of history in the future, if we have a future. So let's think about these very large numbers, because part of this also is people have intuitions. And the problem with very large numbers is that our intuitions tend to be off, since it's not very natural to think about very large numbers. It was the geologists in the 1700s who started to think about deep time, because by their calculations, the glaciation processes they were studying were taking millions of years, but people weren't used to thinking in terms of millions of years. So it took a kind of conceptual breakthrough to even get to that. And then deep space is the same way. The ancient Greeks could take measurements in 6 months apart of the location of a star and do the triangulation, know which stars were closer and which ones were farther by naked eye astronomy. But they had no idea of the distances that they were looking at. In fact, the scale of it, and notice that the civilizations will be away from us in space, but also separated from us in time. It might not only be 1 million light years away, but the civilization might be just 1 million temporal years away, right? So that's another reason why you can't see it. And the scale of that, both in terms of space and time, is so big that there is no contradiction in saying that there are millions and millions of intelligent life forms, and human beings will never detect them, never see a signal from space, never have any solid direct evidence that they exist. There is no contradiction in that, because the numbers are so big it can easily accommodate both of those things being true. So if we never get any evidence of extraterrestrial, like direct evidence, I mean, actually, we already know that it exists. That's my job here, to show you that. So notice then we have this argument, well, is it abundant or is it rare? There's the rare earth hypothesis that, I'm going to talk about the attitudinal issues here in a sec. What I would point out is that there's no standard, there's no norm. I mean, relative to what? It's abundant life in the universe. What would be abundant, what would be rare, compared to what? There's nothing to compare that to. So that's a literally meaningless discussion. What we do have is evidence of our civilization, right? We know about ourselves. So think about this. Think about, you have some pool balls. They're black balls, and some of them are 8 balls. But the ones that are 8 balls, the 8 is turned down to the table. So you don't know which ones, just looking at them, are the 8 balls and which ones are just plain black balls. Now, if you had 2 of these balls on the table, both black balls, and you picked one of them up and it was an 8 ball, and I asked you, okay, you picked one up out of the 2 randomly and it was an 8 ball. So what do you think about the next one? Well, knowing that there are solid black ones, it'd still be reasonable to say, well, I don't really know. I think there's still a 50-50 chance. You said there were both kinds and there are 2 balls here, so I guess the other one is the black one. Okay. Well, what if I had 10 balls on the table and all black and you picked one up at random? And it was the 8 ball. And then I said, do you think any of the other 9 are 8 balls? At that point, look, I mean, I know we can be playing games, but I think ordinary intuition is going to be, yeah. How about if there was 1,000 of them and you picked one up at random and it was an 8 ball? Then I asked you, you think there's any other 8 balls? Now, if you say you don't think there's any other 8 balls, you're being obtuse. When do you say that you know it, that you can use the verb to know? I think probably when you pick up 1 out of 100 randomly and it's the 8 ball. Something around in there. It's a probability function. Now, some people will mention something called the anthropic principle, but this is a misapplication of that. The anthropic principle is this, that, of course, this is the kind of universe where intelligent life exists because we exist in it. And that's a very interesting argument that gets at some things. It's the reason why you can't use the improbability of the finely tuned universe as a proof for the existence of God, for example. But again, that's getting off of our side. The anthropic principle doesn't have much to do with us. I mean, you know, yeah, except for this, I mean, which is what I've been saying for the last couple of minutes here, which is this, that the fact that we're here definitely is, well, it's proof that the universe sustains intelligent life because it sustains us. And that, yes, indeed, is a good reason, not just a reason, but a good one for thinking that when you observe similar conditions in other regions of the universe, you're going to find similar formations such as human beings. Okay. Now, the other big news, though, as I mentioned, is exoplanets. And this is kind of passing a lot of people by, but it's very exciting. We have actually we have now a number of different methods for detecting exoplanets. But probably the most basic one is several variations on transiting. That is, the massy object, the planet, goes in front of the star and it causes a blip. It might be there's actually a light block from the planet, the size of the planet, or it might cause a tidal perturbation, or both. That is, there might be a bulge on the surface of the sun as the massy object is going around it. And that and a couple of other methods. And then finally, the Kepler telescope was built specifically to do this, specifically to search for exoplanets. It's not in service anymore, ran out of fuel, but it gave us magnitudes larger data. When we've finally gone through all of the data that we have from Kepler, it's expected we'll find several thousand more planets. The Goldilocks zone, of course, you know, planets, you've got planets like Mercury, that are too in close to the sun, are kind of burnt, hard rocks, everything got burnt off it. Gassy, big old planets like Neptune or Jupiter are too far away, and so they never kind of congeal. There's sort of big gassy things that never kind of get together. But there's that sweet spot with Earth and you know, Venus on the inside, Mars on the outside, where it's not too close, not too far. And so that's another thing that's looked at. And there are quite a few. Kepler identified quite a few of these planets. There are also size limits and other things. If it's going to be a planet, it's going to have life on it. We have well over 4,000 cataloged exoplanets in our exoplanetary atlas now. And as I say, that's just working through the unanalyzed data of Kepler. The estimate is maybe another 2,000, 3,000, but who knows? We also find that there are planets around binary stars, around white dwarfs, around all kinds of different stars. There are planets around our nearest stars. The latest is that we have planets around Alpha Centauri, the star nearest to us. There's planets around that star. Are there going to be planets with, you know, intelligent lives on them? Probably not, but again, we're not really talking about probabilities here. We're talking about whether there's intelligent life in the universe, and I think that we know that there is intelligent life other than us, by the way. And so what I want to do now then for the next, we only have like 2 slides left, I think, is talk about epistemology a little bit and some of the lessons that we've looked at with epistemology this semester and how that relates to this issue of intelligent life in the universe. You know, prosecutors these days complain because there's all these TV shows, which are these cop shows. We call them forensic crime shows. And they have like the luminol, right? They spray the luminol around and you can see where all the bloodstains used to be and that kind of stuff. And they do autopsies and they dig up the bodies and they find out that they had a couple molecules of this in them and stuff like that. But you know, and so the prosecutors complain that now these people on the jury think that if you don't have that kind of forensic physical evidence, then you don't know it. And then lawyers, defense lawyers can say, hey, you know, they don't have any blood from the scene, and they get people off. As if we don't know things circumstantially. We know most of what we know is circumstantial. Almost all of what we know is circumstantial. Circumstantial is knowing things that you can infer further things from. David Hume would say, among other things, the regularities of the past are things that you can infer regularities of the future from. But, you know, basic, his car's in the driveway. Or think about the busted lovers. I saw his car in the driveway. I know you lied to me, etc., etc. You've seen this scenario. And this is all circumstantial evidence. And again, very oftentimes, in fact, usually you know what's going on. You saw, you know. Forensic evidence is stronger. By the way, also, there is not a clear distinction between circumstantial and forensic or direct evidence. Physical makes it sound like there's a distinction between physical evidence and other kind of evidence. But if I found his trousers on the sofa, that's physical evidence. If I find OJ's blood in the floor of his house, so what? He lives there. His blood's all over the place. If I find his blood at the scene of the murder, well, then, you know, but then the one is circumstantial, the other is forensic. People who say we don't know that intelligent life exists, usually it turns out that they've got an incorrect standard. And I do want to talk a little bit more about that, because now we finally come back to one of the basic themes of our whole epistemology seminar, which is the difference between rationalism and empiricism, and the fact that our scientific methods are really based more in this empiricist tradition, for which knowledge is probabilistic. That is to say, circumstantial. We've done this a couple times, but again, we're coming back home now, closing the loop. Descartes was a mathematician. He thought you knew something when you knew it to a probability of 1, when you had shown its logical necessity, its logical certainty. And so it's not surprising that in the Meditations, Descartes concluded that we knew almost nothing. Particularly, Descartes took the evidence of our sensory experiences to be corrigible, to be dubitable, all of it. So he didn't take it as the standard of knowledge. And David Hume's very reasonable point was that reasonable isn't the same as rational, and you can't be Mr. Spock about it. We know that the sun's going to rise in the east tomorrow, like it always has. We know that. Can I prove it logically to Descartes standards? Actually, no, I can't. I can't prove anything about the future, notice, that way. But I've got regularities of experience, in that case, really, really good ones. So, and based on that, okay, you've got the evidence that there's life all through the universe is absolutely overwhelming. I mean, you absolutely do know it. You're not being careful when you say that you don't know that there's intelligent life in the universe. You're just being obstinate. And so that's what I want to talk about, because what I think, and I mean, I came to this kind of interested also in the mental lives of non-human animals. And I think there's a lot of the same kinds of issues going on here, because at some point with that topic, the issue becomes, it's not the issue about whether the animals have mental experiences and subjective experiences. Of course they do. The question is, who are these people who think that they don't, and what's got into them? And what's got into them is anthropocentrism. Anthropocentrism, the idea that human beings are somehow privileged or special, superior, right? I mean, you could just be, a plain old thug and say you just care about humans because they're humans and you're one, but that's not really the same here. That person would only want to just, kill the aliens, I guess. They wouldn't necessarily refuse to believe in them. The person who's refusing to believe in them is the person who just doesn't want what the church didn't want from Galileo, which is this decentering, this saying, well, the humans aren't it. They're not the sine qua non. They're not the be all and end all. They're not even the best. They're not even the most intelligent, whatever that is. So, no, we don't have a problem with knowing that the universe is full of life. We know that, and we've just gone over the reasons why we know that. And we've known that for a long time, as Kant pointed out in the 1790s. As I said, a moment ago, to me, the more interesting problem here is psychological. Right? The problem isn't, why are people willfully perverse about this topic? Because that's what they are. People who should be smarter, people who should know better. Again, just as with the animal mental experiences. Biases are a product of ego. It's kind of ego. That's one reason. There's two reasons. So one is this ego. So that's first and second bullet point, second and third bullet point there. Notice the concept of intelligence. What is that? Are rabbits intelligent? You talk about human beings being alone in the universe. I don't know, we're with rabbits. are here with us. The birds and fishes, we're not alone. Uh, there's no reason to think that there are beings that aren't more intelligent than humans. I'll grant you that rabbits are not as intelligent as humans, I don't think. Whatever intelligence means, right? But gosh, you think humans are the most intelligent that there is? Yeah, what does it even mean? Yeah, but so that's one problem. The other problem, though, is deeper. That's the last bullet point, is what I was talking about at the beginning. It's this Cartesian mind-body stuff. So really baked in is an idea that human beings are unique. There's nothing like them. And then also that humans are miracles. Miracle, an exception to the laws of nature, a God-driven thing. And you talk to a skeptic, someone who sees himself as an educated scientific person, and you just don't think we have evidence that there's intelligent life on other planets. Their view doesn't have any support, but the view that there is intelligent life on Earth has lots and lots of support. Their view does not. I think they just sort of really, although they see themselves maybe as being a hard-headed empiricist, are actually someone who's sort of internalized kind of mind-body dualist idea that humans are miracles or something. It looks that way to me. So that would be some kind of diagnosis of it. So then, there's a big irony there. I think this is the last thing I have to say about it. This is ironic. What's ironic? That the people who say we don't know that there's intelligent life in the universe say that they're scientific. They claim that they're being hard-headed empiricists. They're not the lotus-eating hippies who think that there's intelligent life in the universe. Oh no, they're hard-headed natural scientists. That's asinine. These people are merely confused about the scientific method, about empiricism itself, which produces only probabilistic knowledge. And by those standards, and relative to many other things we believe, our confident belief that there's intelligent life in the universe is very, very well justified indeed. A lot better justified, for example, than that your in-laws are going to be nice to you next vacation. A lot better justified than that you're going to be able to get tickets to the Eric Clapton concert. You know that there's intelligent life in the universe. It's a much higher probability than that you know either of those things. These are emotional motives. And as I say, they tie in directly to this views about non-human animals as well. So, and I think that's the most interesting thing. The science is kind of interesting though too, the stuff that we went over earlier in the presentation here. Because what is it? Well, it's the evidence. It's the evidence that people don't want. They don't want to swallow the medicine. Why? I get it that a lot of people just don't care about stuff like this. I don't understand why they don't care, but I get it that they don't. But this is something a little bit different. This is being willfully obtuse. This is being willfully perverse about it, And I do think it's important. I do think it's important for understanding a lot of things. Think about exopsychology, for example, exobiology, exogeology. Well, we have rocks from other planets, so we have real exogeology. We have geologists who can actually look at rocks from other planets because we have some. Exobiology is thinking about what has to be true about any life form, because what's going to be amazing is going to be to see the similarities and the differences. That's what's going to be mind-blowing. Both will be mind-blowing, both the similarity and the difference, when we finally see a large evolved creature, if we ever do. That's an extraterrestrial creature. We may very well never see such a thing. I understand that perfectly well. I don't believe the alien beings have ever visited the Earth. I don't know that they have, and I suspect they haven't. I don't think it would make sense to move. First of all, I don't know how you could move physical objects in those kinds of distances, and some, pretty seat of the pants physics is going to say that you can't. Just to be clear on that. But we do know that there's lots of extraterrestrial life in the universe. And I think it makes a difference. It puts us in our place. It is part of a narrative that's been going on for hundreds of years. It's nothing new. And what is our purpose today? Our purpose today was to go over to some of the work that we've done on some concepts of knowledge, justification, belief, rationalism, empiricism, and apply those to a real case. And you're free to disagree with me. My argument, forensically, another use of the word forensics, is that yes, indeed, we do know. That is, I can properly use and correctly use the verb to know when I say that I know that there are intelligent life forms in other places in the universe. That's what I say. All right. So we'll see. And anyway, it's been nice doing this long distance. I think. I don't know it since we're not there yet.